Hello everyone, this is Khashir. Welcome to part 1 of solar system tutorial with Python and Turtle. Actually, the solar system, the final version, doesn't have any kind of mechanic or physics to it. So it's like just a bunch of objects or orbiting around the sun. But it can be a little bit complicated, this is a little bit. So I've been thinking like, let's make most of this tutorial. So I'm going to show you how to create very simple orbiting objects, and after I'm going to write the same program that I showed you before with functions, and after writing it again same program with classes. So our goal is to write this orbiting using classes, but first we need to start with this very simple orbiting stuff so we can learn a little bit of some methods that are available in Turtle. Okay, then let's create one file. We call it, or whatever you want to call it, solar. I call it solar script. .py. Okay, and first of all, import Turtle, and we need to take care of our screen. So we create our screen normally this way: screen equal turtle.screen with capital S. Okay, and screen.bg color, which is background color, is black. So all the colors, when you want to specify any colors and have them as arguments in Turtle, you have to use them as a string. And now we should have screen. So we save this and going to my tutorial folder. Okay, and here I have solar script and py solar underscore script dot py. I don't know if you can see it, but the screen just popped up and disappeared. This is because we don't have any loop to keep the screen up and running. So for now, we use turtle.main loop. Okay. And now we have the screen up and running and looks good. Okay. Now let's create our center object, which is sun. We can call it just sun equal turtle.pan because we are not going to use all of these aspects and attributes from the turtle. So turtle.pen is enough. Sun.pen up means we are detaching the pen from the screen. Like imagine as a turtle, like there is a turtle robot is like moving around, and at the bottom have some kind of pen or pencil, some kind of drawing system, and by moving we can draw stuff. Actually, this turtle was part of the logo programming, and after they just use it in Python. So pen up, and after sun dot set position will be 0 and 5. And after self, actually, yeah, not self, I thought it's a class, sun dot shape, of course, will be circle. And if you don't know, turtle doesn't have so many default shapes. It's circle, triangle, square, I think arrow, and classic, and turtle itself. And for the rest, you need to write them as a function or import them as an external file with I think GIF. It should be just GIF format. It doesn't accept any other format. Sun dot shape size will be 4. We need to have big sun. Then we take care of the color. Sun dot color is yellow, and sun dot fill color will be also yellow, right? Ctrl S, and when we run this script, we should have sun center of the screen, almost center of the screen. So here we have sun at 0, x0, and y5. Because it's a little bit tricky we can move just using the circle method itself around another object. Alright, let's create another object to orbit around the sun. So we call it just dot for now. Dot equal turtle dot pen, and almost the rest we can copy from up. So C, and we can click here, and we just change the sun to the dot. And we change other stuff a little bit. Set position will be 0, -50. It will be a little bit far from this from the sun. Shape will be circle, of course. Shape size will be small, will be 0.5, and color will be white, or I don't know, red. No, let's make it white. And we don't need to have fill color here. But what we need to have is dot speed. And speed is the speed of drawing. We put it for now for 2, and you can have it from 0 to 10, and 0 is fastest, I think, and 10 is slowest. And now let's just make it orbit around the sun. But now we need to have another loop, the loop that we can have something under it. We need to have a while loop. So let's get rid of this loop, and we say running equal true, and while running, then dot circle 50 and 1. It means we are going to draw the circle with that dot, but because the pen is detached from the screen, we use here pen up. Actually, I forgot to write here, so dot pen up. There's not going to draw anything, but we still can see the object is moving around without drawing. It's same as you are moving your pencil or pen without writing anything. Then when we now run this code, we will have this little object moving slowly around the sun. But if you can notice, we can kind of see the system is drawing this little circle around the sun, so it's going very very, and we can make it move faster and more smooth. There we can use something called screen tracer. Is one of the screen methods available in Turtle. So here screen.tracer, we can have it false here, and to complete this loop between screen tracer and we need to have screen update. So screen tracer is controlling the drawing process on the canvas. It actually is not a canvas, but around on the screen. And by screen update, we are calling that method actually. So for example, imagine we are drawing one circle like 10 times a frame, for example, but this with screen tracer and update, we are just showing the last part of that 10 times drawing. It means we don't see the drawing itself, we just see the result. Same goes with display flip in Pygame. Same, almost the same, almost, but technically they are different, but the idea is kind of same. And here screen.update, and we just have something is okay, screen, not screen. Okay, now it's too fast. Then we can make it this way. Dot fill color. Let's make it black. One time, Control S. Still very fast. Then we need to make it slower a little bit, so we can get rid of this fill color. And now we can have other options. Let's play with the screen tracer itself, like make it 2. Now is better. So this is kind of experimental. Let's make it 3. No, the 2 was better, so we keep it 2. Another thing, before I keep it on 2, let's make it 0 or false. Actually, it doesn't matter. You can like have this parameter as 0. Make this one 4. Still same. Make it, for example, 7. Or make it for 1 now. All right, what about make it 1 and screen tracer also 1? It's too slow. Make it 1 and screen tracer 2. Okay, this looks like most optimal speed and smoothness for us. All right, let's make another dot here. We call it dot 2, but instead we can just copy everything here. Control S, V, and we call them dot 1 or dot 2. And we just change some small things. For example, change the position to 80, minus 80. The circle, the size will be a little bit bigger, maybe 1, and color will be white, speed will be 3. What do you think? Because we can have different speeds around orbiting objects around our sun. So here we can also write dot circle, dot 2 actually, dot circle, something like 70 and 0.5. It means like, okay, all right, that's okay. We have two objects running with different speed around the sun. Now we are ready to make our Earth. Then we can have here Earth equal turtle.pan, and again we can just copy everything from here and change them to Earth. And here and position we can have it on 120, for example. Circle shape size will be 1.5, a little bit bigger than others, and the color will be blue. Also Earth dot real color will be blue. Actually, let's change the another speed to 5 and change our speed of Earth to 3. And now we just add the Earth to game loop or main loop. So Earth dot circle 90 0.3. Oh, something goes wrong. Earth is orbiting around something else. So, because this should be negative here. Alright, now it's better. Now we have three objects, and Earth is very strangely orbiting around the Sun. Maybe minus 120 was too much. We can make it 100. Yeah, but they're crushing. Yeah, never mind. This is just demo how to move the objects around another object orbiting. It's very simple orbiting. Now before I finish this tutorial, let's make a moon and put it around the Earth. So in this tutorial, I'm not going to orbit the moon around the Earth, but I'm going to orbit the position of the moon with the Earth around the Sun, something like that. So moon again equal turtle.pan with capital pen P, and this is 2 4. And instead of copy, let's write it. Don't be so lazy. So moon dot pen up and moon dot, we can have it speed equal 0 and moon dot shape, of course it's circle, and moon dot shape size is 0.4 or 3, 0.4, and moon dot pen color is of course white, and moon.fill color is again white. Then now we are ready to add the moon to our main loop, but the way we are going to add moon is a little bit different because we want to connect the moon to another object orbiting to second object. So we can say moon dot go to, right, earth dot x core and earth dot y core minus something, let's say minus 20. Okay, and now when we run it, we have a moon that is moving with Earth, but it's not orbiting around the Earth. That would be something for our next tutorial. So that would be all for this tutorial. I hope you liked it. Oh, they crashed. But the real work will be from next tutorial. This was kind of very basic introduction for this solar system, which is really the very demo solar system. There is no physics or mechanic exactly as it should be. Okay, that would be it. So if you like my videos, my tutorials, please subscribe. Thanks for watching, and I see you in next video.